Now, NAT types, we have static NAT. So this doesn't apply. I said general NAT types. It applies to both the ASA and the iOS. So static NAT means a manual binding of one IP or subnet to another IP or subnet. And because it's going to be a static NAT, it means you manually do that one-to-one binding, which means the translation is always active, never expires. And because the translation is always active, never expires, traffic can be initiated both ways. This is useful in general for providing connectivity between overlapping networks or with publicly available services. Like, for example, if you look at our diagram, so supposing that this server A, let's say, so this has, let's suppose that PCA runs a public service, and I want somebody from the internet to be able to access PCA, which now is not possible because it is a private address. So what I'm going to do is I'm going to make this interface to be likewise inside NAT, this interface to be outside NAT facing the internet. And what I'm going to do is I'm going to configure on router 1 a static one-to-one binding between 10.10.11.100 to a public address which is routable. It's going to be to, let's say, 9.9.9.9. So I'm going to do a static one-to-one translation of 10.10.10.11 to 9.9.9.9. It's going to be a one-to-one translation, which means as PCA is going to initiate traffic out to the internet, traffic gets sourced with 10.10.10.100, but as the router routes the traffic out on the internet, it's going to change the source to be as the traffic leaves. So the PCA sends the traffic, reaches the router, and that traffic has initially a source of 10.10.100. But as the router routes the traffic on the outside NAT interface, it changes the source to be 999. So traffic can be initiated inside outside. But likewise, because this was the scope of the static NAT, because it's a one-to-one binding which is always active, it also means that if somebody wants to initiate traffic to PCA, because it's a public service, whatever the service is, that somebody is going to initiate traffic distant to the public address of PCA 999. And then when router 1 routes the traffic in the LAN network on the inside NAT interface, it's going to change the destination to be 10.10.10.11.100. So in this case, the router performs destination NAT as a result of the traffic flow. So because the static entry is always active, traffic can be initiated both ways. So that's one use case of a static NAT in there. Or as I stated for overlapping networks, if this is 10.10.11.10.11.0/24, and this is likewise 10.10.11.0/24, because those are two different companies, and they want to communicate one to another. If they want to provide communication between the same overlapping subnets, both of their router gateways have to perform a static one-to-one binding. It means that, for example, router 2 is going to NAT 10.10.10.11 as traffic leaves out into, let's say, 20.20.11.0/24, and router 1 is going to NAT traffic with a source of that 10.10.10 as it leaves the network. Is going to NAT it to, let's say, 30.30.11.0/24. So it's going to be, this is going to be a subnet to subnet mapping to provide connectivity between overlapping networks. Then we have static path, which is a variation of static NAT. So this is going to be a manual binding of one socket this time. So it's not going to be a manual binding of an IP to an IP, but a socket to another socket, which means a socket is defined by the layer 3 information and the layer 4 information. So IP and TCP port map to another socket IP and TCP port. And this is what in general you're going to use for providing connectivity from the internet to public server services. Because if PCA runs a public web server in here, which means it's reachable on TCP port 80, and it has an IP, PCA has an IP of 10.10.11.100. Just to allow connectivity from the internet with our web service, it doesn't make sense that on router 1 you consume one public IP to do a 10.10.10, 10.10.11.100 mapping to a public IP of 999. Doesn't make sense to completely consume one IP address just for one service. So what you're going to do is on router 1, you're going to do a static port ID translation. You're going to say that 10.10.11.100 for TCP port 80, that's on the LAN side, is visible on the internet as 999 TCP port 80. So this is called static port ID translation because it's not a one-to-one IP binding. So that IP of 999 is not dedicated to 10.10.11.100. Only for this port 80, for this TCP port 80 traffic, that 999 maps to 10.10.11.100. Which means you can use that public address of 999 for other services as well. Like you can go on that router and also state that if you have another PC in here, with an address of let's say 200, and that runs a SMTP server, so it's reachable on TCP port 25. You're going to go on router 1 and say that 10.10.10 11.200 on port TCP, so 10.10.10 11.200 on TCP port 25 is visible on the internet also as 999, but on TCP port 25. So as you can see, the same public IP address now, because it's not a one-to-one mapping, the same public IP address of 999 can be used to identify multiple inside hosts, but for different services. So this is what in general you're going to do for allowing traffic to come in the network from the internet to public IP services. Now, dynamic NAT, as opposed to, that's a common misconception that dynamic NAT is, so let me tell you how it works. So dynamic NAT is a dynamic binding, not a static binding of one IP subnet to another IP subnet. So because it's dynamically built, it means that translation is being done on demand. It's not always present, as interesting traffic shows up on the router, so the router has to do the translation. So with dynamic NAT, at first traffic has to be initiated one way only, and after translation is being done, it can be initiated both ways. So initial traffic can flow only one way because the translation is not active to begin with. But once the translation is being done, it can be initiated both ways. So it's still a one-to-one IP to IP binding, but it's dynamically being done. So it makes sense that as soon as the translation is done and you have a one-to-one binding, traffic can be initiated both ways. And that's a misconception. That some engineers believe that dynamic NAT doesn't allow traffic to be initiated both ways. It is wrong. So if I would take the same example where this 10.10.10.11.100, this IP, this host of 10.10.10.11.100, I choose to NAT it. So on router 1, I'm going to do a dynamic NAT this time, dynamic NAT, which states that 10.10.10.11.100 is mapped to 999. What this means, because this is dynamically being done, it means that initially somebody from the internet cannot initiate traffic destined to 999 because the translation is not being done, is not active. The real IP 10.10.10.11 has to initiate some traffic out on the internet. So the router does the translation. Translation shows up in the translation table, that one-to-one mapping dynamically built. And once that has been done, then here somebody from the internet can also initiate traffic, now destined to 999. And as the router routes traffic back on the LAN, it's going to change the destination back to the original IP of 10.10.11.100. So traffic can still flow both ways, but you have to first make the translation happen, which means the host which gets translated has to initiate some traffic for translation to show up in the NAT table of the router. Dynamic path is a variation of dynamic NAT. It's also known as NAT overload because of the configuration option, or path, port edit translation. This one is a dynamic binding of multiple IP addresses, like from the LAN, into a single or fewer IP addresses alongside with TCP and UDP port translation. And in general, with dynamic path, traffic can only be initiated one way. Especially if you use a single IP, a single public IP, to represent all of your inside hosts. So a dynamic path is no longer a one-to-one IP to IP binding. It's going to be multiple to fewer, which clearly makes sense that traffic can only be initiated one way, not two ways. This is in general used to provide internet connectivity to LAN systems, because clearly on the LAN you're going to have a huge amount of IPs. On the LAN you have in here a stage 24, and maybe this small company has one single public IP, which is 999. So as traffic goes out on the internet, all of those 254 hosts from VLAN 11 are going to be known in the internet as 999. So because it's not a one-to-one mapping, it means that nobody from the internet can initiate traffic destined to 999. They can only reply, because this IP is not dedicated to a single host in there. Policy NAT, it's a variation of either static or dynamic NAT. And as the name states, translation is being done like based on a policy. Only if specific conditions are met. So policy NAT allows one socket IP and TCP port to be translated into another socket based on the destination of user traffic. So it's useful when you want one IP or one subnet to be translated differently based on the resource being accessed. Like for example, as PCA sends traffic out on the internet, I want that source of PCA, which is 10.10.10, 10.10.11.100, to be NATed to that 999, my public IP address. But as PCA sends traffic to this, SVTI tunnel or Jerry tunnel to my headquarters, to this destination, either I want no traffic to occur, So based on the destination, I'm going to do NAT or not do NAT. Or I may want the source to be netted to something else. Let's say 192.168.10.100. So as you can see, based on the destination being accessed, I'm gonna want to either do NAT differently, so to translate the source into something else, or as I go to the internet do NAT, as I go to the private network don't do NAT. So it depends what I want to achieve in the end. But in the end, both options are the same. So if I do NAT on the internet and NAT on when I reach the remote site or in different sources, that's still policy NAT. If I do NAT out on the internet and no NAT out on the other side, it's still policy NAT. Because based on the destination, I choose to NAT or not to NAT, or I choose to NAT differently. Now, as a system performs NAT, it has to keep track of the changes it made to an IP flow, which means those changes are going to be kept in the NAT or translation table. Now, a couple of NAT considerations. As a device NATs a traffic flow, an IP traffic flow, it may break that traffic functionality. So it may break the traffic flow. For example, AH, which is an encapsulation of IPsec, does not support NAT for a simple reason. And ESP, to be NAT aware, it requires NAT-T to be negotiated between the NAT devices in most cases, between the VPN gateways. So if you route ESP traffic to a NAT device, and that NAT device is going to NAT the ESP traffic, you'd need that the VPN gateways of the VPN tunnel have negotiated NAT-T, NAT traversal in most cases. It can work without that. It's another discussion. Now also some applications like FTP, H323, or LDAP, or SIP, they embed the IP address information at the application layer. Which means for that application to work through a NAT device, the IP from the application layer has to also be translated. This capability is called application layer gateway on Cisco devices. Like for example, as I stated, if you have an FTP server in the internet, actually, give me a couple of seconds. If PCA is the FTP server, which has that address of 10.10.11.100, which is actually visible out on the internet as 9999. Now, as somebody from the internet, a FTP client, it is going to it's going to initiate first to begin with the control plane session to the FTP server. Initiate that over to 999. So let's say the control plane session works. But then what the server, depending of course how the server runs in active or passive mode, when the server replies over that control plane session to the client, it's going to tell the client, when the server replies to the client, it's going to build an IP packet with a source of that so the FTP service builds an IP packet with a source of its private address 10.10.10.11.100 and a destination of whatever the FTP client is. And in the FTP payload, at the FTP payload level, in the FTP payload at the application layer, it's going to tell the client connect for the data plane session to me on the IP of 10.10.10.11.100 Connect, let me use the color of black to be more visible. Connect to 10.10.10.11.100 at port number whatever, XYZ. So as this packet flows through my NAT device, which is router 1, if my NAT device changes only the IP address from the IP header to 999 and doesn't also change the IP address from the payload level, from the FTP payload level to 999, so if my router is not application layer gateway capable to also change the embedded IP address from the application layer to NAT as well, then the transfer session of the FTP is not going to work. Because if my NAT gateway NATs only the IP address from the IP header, when the FTP client receives this packet, he's going to try to connect to the IP address as presented at the application layer. And of course, that's not going to work, clearly. So that's why in some cases, so those kind of sessions may work or may not work. It depends on the NAT configuration and also on the capabilities of the NAT device, if it can understand the application and also translate the embedded IP addresses from the application layer.